We physicists have waited 100 years since 1916 for this photograph.
A theoretical physicist has spent his life exploring the deepest mysteries of the universe. Now, he's on a mission to change the very laws that explain our existence. Dr. Kaku, one of the greatest scientific minds of our time, believes we might be living inside a black hole. Think about that for a moment. Everything we know, our entire reality and sense of time and space, could be inside a massive black hole. But what is a black hole? How did it form? And what happens inside it? Join us on this incredible journey to uncover these secrets and explore the mind-blowing possibilities within a black hole. We'll also look at new images from the James Webb Telescope, which suggest the Big Bang might not have happened the way we thought. Get ready to have your understanding of the universe turned inside out. According to some scientists, black holes aren't just ordinary pitch-black voids in space. They are far more intricate than that. These cosmic wonders, they believe, are colossal concentrations of matter compressed into an unbelievably minuscule space. They are 10 times more massive than our fiery sun, compacted into a sphere no larger than the bustling city of New York. They are cosmic regions where gravity is incredibly intense, possessing an unstoppable force that engulfs everything, even light itself. These enigmatic entities remain invisible to our eyes, but their presence becomes evident through the impact they have on surrounding matter. Swirling around certain black holes are disks comprised of gas and dust, rapidly twirling with immense energy. As a result, they unleash massive amounts of radiation, earning them the name quasars. Remarkably, quasars shine with unparalleled brilliance, establishing their status as some of the most dazzling entities in the vast expanse of the universe. But how do these captivating black holes come into existence? Well, scientists believe that there are various kinds of black holes, all distinguished by their size and origin. The most common variety, known as stellar black holes, materialize when colossal stars reach the end of their lives and implode under the weight of their own gravitational pull. These particular black holes can possess masses up to 20 times that of our Sun, yet have a mere diameter of a few kilometers. However, more colossal and exceptionally rare black holes exist, known as supermassive black holes. These monstrous entities boast staggering masses measuring in the millions or even billions of suns. In terms of size, their diameters extend into the millions of kilometers. Astonishingly, they tend to take up residence at the heart of galaxies, including our very own Milky Way. Curiously enough, the exact process by which black holes form remains a puzzle for scientists to solve. One theory suggests that they may have originated from smaller black holes merging with each other, or even absorbing nearby stars across vast stretches of time. While some scientists at NASA have affiliated their origin to the Big Bang, the arrival of the James Webb Space Telescope has since cast doubt on the unshakable nature of the Big Bang theory. Due to Webb's groundbreaking observations, astronomers have now found themselves challenged to re-evaluate their understanding of the universe's origins. Celebrated theoretical physicist Michio Kaku, reputed for not being one to mince words, has also enthusiastically described the recent shocking discoveries made by the JWST. According to Kaku, the JWST has completely upset the established order, causing us to question everything we thought we knew. The realization is sinking in that we may need to rewrite the textbooks that detail the genesis of the universe. But what precisely has the JWST unveiled that has eminent scientists rethinking their stance on the universe's birth? Well, Kaku has shed light on the matter. In his own words, creating a galaxy like the Milky Way, with its 100 billion stars, takes countless billions of years. However, the James Webb Telescope has detected 6 galaxies that existed a mere 500 million years after the Big Bang. Astonishingly, these galaxies are up to 10 times larger than the Milky Way itself. This revelation shouldn't be possible. So why does the discovery of these 6 immense galaxies pose a problem for astronomers grappling with the origin of the universe? Kaku believes that the issue lies in the fact that there should not be primordial galaxies surpassing the size of our Milky Way, especially when they are only 500 million years old. He expressed further that something is clearly amiss, and it seems we may have to revisit and revise our theories on how the universe came into existence. The galaxies in question, as described by Kaku, contain tens to hundreds of billions of stars. They emerged at a time when the universe was a mere 500 to 700 million years old. This timeline is significantly earlier and faster than what current models of galaxy formation suggest. According to these models, celestial matter progressively clustered together over time. The puzzle of how these galaxies attain such colossal size in such a short period might demand new insights from the realm of physics or the development of novel techniques for galaxy creation. As Kaku aptly terms them, the remarkable discovery of these universe breakers highlights the JWST's ability to provide us with an entirely fresh perspective on the cosmos's early history and evolution. It is unveiling a new chapter in our understanding of the universe, one that challenges our existing notions and compels us to explore uncharted territories of knowledge. Amidst these revelations, Michio Kaku offers an alternative explanation for the latest discoveries. He suggests that the JWST may have encountered black holes instead of baby galaxies. These enigmatic objects defy conventional explanations, as they don't align with the typical sequence of galaxy formation. Kaku proposes the intriguing idea that these could be monstrous black holes born from the aftermath of creation itself. Such a notion perplexes scientists, hinting at the emergence of new laws of physics within these mysterious cosmic entities. Contemplating the cosmos, another related theory proposes that the universe itself is a colossal black hole. This mind-bending concept suggests that our universe originated from the collapse of a gargantuan black hole, giving birth to an even larger cosmos. Beyond the event horizon of a black hole, where gravity is so intense that nothing can escape, space-time becomes distorted and twisted, leading to a singularity, a point of infinite density and curvature. Some scientists entertain the possibility that instead of a singularity, there could be another event horizon within the black hole, opening up to an alternate world governed by different physical laws. This intriguing notion implies that our universe resides within a black hole, nested inside another universe. The hypothesis further suggests the existence of other universes within other black holes. These cosmic enigmas, these black holes, might not be one-way traps, but rather portals to diverse realms of space and time. While theoretical models and mathematical computations support this idea, no observational evidence or experiments have yet validated or proven it. Nevertheless, one of the primary objectives of this theory is to address the question of what transpired before the Big Bang, the widely accepted origin of our universe. The Big Bang theory describes the universe's birth from a hot, dense state of matter and energy approximately 13.8 billion years ago. However, it fails to explain what triggered this initial condition or what preceded it. Many physicists have argued that our universe was devoid of activity before the Big Bang, as time itself commenced at that very moment. Consequently, questioning what occurred before becomes meaningless and futile. Nevertheless, some physicists, including Kaku, have remained dissatisfied with this explanation and continue to strive to uncover a more profound explanation for the creation of our universe. One compelling theory has already posited that our universe evolved from a black hole in another universe, offering an intriguing perspective on our cosmic origins. This fascinating concept was introduced by a Russian physicist named Egon Novakovich in 1973. Since then, other physicists like Lee Smolin, Nikodem Poplawski, and the renowned Stephen Hawking have expanded upon it. According to this mind-boggling theory, our universe could be just one among countless others within a vast expanse called the multiverse. Each universe in this multiverse has its own distinct set of physical laws, creating an awe-inspiring diversity. Imagine these universes as separate entities, each with its own rules and characteristics. Some of them might even house extraordinary phenomena like black holes capable of giving birth to entirely new universes. Now you might wonder how this is possible. Let's delve into it. Now here's where it gets truly mind-bending. These new spacetime regions could be new worlds with entirely different physical laws. Picture them as separate universes distinct from their parent universes. The boundaries separating these universes from their parent are known as the event horizon. It acts as an invisible barrier beyond which nothing can escape or communicate. The parent and newly formed universe would have their own event horizons. The parent universe's event horizon would be located outside the black hole, while the child universe's event horizon would be situated within the black hole itself. This remarkable scenario envisions a cosmic separation between the two universes, each with its own unique properties. So within the enigmatic depths of a black hole, the formation of new universes could be occurring, expanding the boundaries of our understanding and revealing the infinite possibilities that lie within the vast tapestry of the multiverse. Interestingly, yet another idea suggests that these newly discovered regions of spacetime might be wormholes, shortcuts, or tunnels in the fabric of spacetime. Wormholes are hypothetical solutions to Einstein's general relativity equations, although their existence has never been observed or proven. In this fascinating scenario, each end of the wormhole would connect to distinct worlds. One end would be inside a parent black hole, specifically within its event horizon, while the other would be outside a child black hole's event horizon. Interestingly, matter and energy that falls into a black hole in one universe could potentially emerge as a white hole in another universe. Unlike a black hole that nothing can escape from, a white hole acts as a region of space where nothing can enter, but everything can leave. It serves as a seed or source for a new universe, providing the necessary ingredients: matter, energy, space, time, and even physical laws. This intriguing process could perpetuate endlessly, resulting in an infinite hierarchy or network of universes within universes. In a playfully nested twist, each universe within this vast cosmic tapestry possesses its own unique history, evolution, structure, composition, and ultimate fate. Some worlds may resemble our own, while others might exhibit striking differences. There could be older universes and younger ones, isolated realms and interconnected ones. Interactions and collisions between these universes are also plausible. This theory offers a compelling explanation for the existence of our universe, its origins, composition, and destiny. Furthermore, it presents potential solutions to various cosmological enigmas. For instance, it sheds light on why our universe possesses lower entropy, finely tuned physical constants, and inflationary expansion. Thanks for watching another episode of Astro Lumen. While you're still here, make sure to click the video on your screen for more quality content.